Okay. So, welcome back. In this lecture we will discuss how we differentiate between natural and road dust aerosols. So, we will be discussing that what are the characteristics and how can we differentiate the natural aerosols with the road dust. This is very important topic, and this topic is becoming increasingly very important, especially for the students who are studying in the MSc or who are doing PhDs. So, this could be one of the very important research topic as well, actually, the distinction between the natural and road dust characteristics. So, in the previous lectures I discussed about what is the actually road dust characteristics, and in the road dust previous lecture we mostly discussed about road dust. Basically, we classified based on the size, okay, that the size typically less than 75 micron particles, they are actually defined as the road dust, and it is not actually very important, this is the only one criteria, but as we know that there could be more than one sources of urban aerosols or road dust. So, how will you differentiate between these two? So, if you just see here actually like composition of dust, what the dust here I means, this is actually a natural source. So, that source that is actually if you just which has been measured by different things, so as the oxides in the continental crust, and this is also called upper continental crust, okay, abundance of major elements in the upper continental crust and major elements as oxides. So, this is we are talking about the UCC values, upper continental crust values, which is generally taken from different places and then put together, and what would be the average composition. So, if the composition is deviating from this one, this means there has been either removal or the addition of some of the elements in this one, and that is how we distinguish that whether the dust aerosols is actually natural or kind of artificial anthropogenic. So, as we know that most important element in the dust is actually silica, and its constitute silica is actually SiO2 constitute more than 60, actually to be precise 60.5%, 61.5% or so. Then the next source is actually percentage of this is see there are two things that are given. This is elemental percentage and this is actually percentage of the oxides, and this value is given by weight percentage. So, just remember these two things that are very important. If you remember my previous lectures, I have discussed very categorically about the different units that can be used in this one, and I also discussed with you all that aluminum is actually like usually it is taken at 8%, but it is very close to 7.7% or so, but usually they are taken as 8% has been taken to calculate what would be the dust in the aerosols or in the road dust. So, this is very important, provided one question that must trigger to your mind, that why aluminum is actually used as a indicator for the road dust. The reason is very simple, that aluminum is actually very conservative tracer. So, this means it has no additional source or no anthropogenic source, but yes, now there have been actually lots of aluminum manufacturing industries are coming. From there, this part of aluminum can be actually generated, and that can become part of the aerosols, and then road dust are part of the dust aerosols. So, this is becoming very important, but because of this conservative nature of aluminum is taken as a tracer for constructing the road dust. And then the third element that is very important is iron, and iron is also very important for studying our what you call nutrient cycle. We will discuss this one in the coming few slides, that how the nutrient cycle is important. Then there is another very important element is calcium, okay. So, this calcium is also about 2.945 or 2.9%, and then you have sodium. Sodium is also very important here, okay. So, usually sometimes sodium and aluminum, these two are usually taken as a conservative sources or for the tracers for the urban dust aerosols. But if you have to reconstitute dust composition or dust contribution and how much is the total dust mass, then usually aluminum is preferred over sodium. Magnesium, so there will be a kind of very good correlation between magnesium and calcium, because they belong to the they have the similar, belong to the same group of elements, and they are often present in a similar form. Then potassium is also present in some amount, say like about 2.8%. Titanium, beryllium and manganese, these are also very important. So some of the times titanium is also taken as a source of natural dust aerosols. So this is very important. Not only that, apart from this one, you can also use their elemental ratios. For example, you can use iron to aluminum, and if the ratio is high or low, you can discuss about this one, because if the ratio is high, then this means either iron has been added in the sample or aluminum has been removed. But because aluminum is not generally removed, because it is chemically inert, there is no chemical reaction is involved, and the aluminum is not involved in any chemical reactions or most of the chemical reactions. So what will happen? Aluminum will not be removed from for the system, and therefore this iron becomes very important, and this can be used actually, like how much iron is actually coming and from there is coming. It has become actually like atmospheric iron. This is becoming very important and significant source of nutrients in the urban areas. So this is the actually like relative percentage in different kind of samples, and if you see here, almost they are northern Sahara, Soviet Central Asia, southwestern India and sedimentary rocks. If you see the composition, they are actually like aluminum is somewhere around 8% or so, or little bit between 7 and 8%. You can just see little bit variations here. Then in this silica is somewhere around 25-30%, sometimes actually more. But if you see here 30%, this is on the higher side. If you take average of these samples, it would be just somewhere around 30%, 25 or 26% or so. Similarly, potassium, calcium and iron, they are actually, these are also called major elements. So just note down, these are also major elements, and we will also discuss that major elements. We will discuss about the heavy elements as well. Okay, so these are the major elements that are present in the dust. So this is how the dust is there. The composition, if you talk about that different, what are the chemical formulas of common clay and minerals, that common clays and minerals in the dust. So calcite is very important, calcium carbonate. Then you have calcium, then chloride you can have chondrome, which is very important source of aluminum. You can see Al2O3, and then dolomite, calcium magnesium carbonate. So this is also very important here. Here calcium magnesium and carbonate is there. Then you have gypsum, calcium sulfate with some water content in this one, halite, hemite is very important, and we will discuss in the absorption. Then hematite is an absorbing aerosols that is present in the atmosphere. So this contribute, and because of this contribution, road dust is also becoming absorbing in this one. And you see lots of composition becoming very complex here, but most of the time they will be composed of potassium, iron, aluminum, magnesium, again iron and some form of sulfate, silica and aluminum. Then of course with the ligands and bindings, you can have like OH or some of the hydrated or completely dehydrated form. So this becomes very important. There is a very important source of magnesium is magnesite. Okay, so MgCO3 is already there. And the silicate quartz or silica, this is actually silicon dioxide. So silicon dioxide is very important source of these aerosols in the atmosphere. And if you see the weight percent, their weight percent, then in the different islands, Barbados, like Sal Island, and then Miami, they have been, their composition has been measured, and then the composition has been found out, and lots of research has been done, and you can see the variability. Unlike the other things, you can see the composition, but that the composition is mainly derived by mica or elite. Mica is also like SiO2. So, this is very important, not SiO2, quartz is there actually as a SiO2. So, you see this quartz is second dominant species here, but then elite or mica is very prominent here. So, they are actually like can have different kind of dust aerosols, and different types of dust, the composition of dust can be different depending on this one. So, the next question becomes that how they can actually be used to measure this one. So, I talked about, if you just remember, I talked about this aluminum, magnesium, calcium, potassium and iron, these are the major elements. So, apart from this one, you just measure other elements, like we measure manganese, generally we measure manganese, we measure copper, we measure nickel. Okay. These are actually like heavy metals. There are many other heavy metals like lead is there, cadmium is there, we measure everything. For example, here we will discuss this one. So, we defined a factor that is called enrichment factor. Enrichment factor is the ratio of the element with respect to aluminum in the upper continental crust and the ratio of that element with respect to aluminum in the sample. So, as the name said, that enrichment factor. So, basically if you just take the concentration, if you can say that okay, why do not we take actually x in sample, concentration in the sample, and x in the upper continental crust. So, if you take the concentration itself, this could also be actually used as defined as a enrichment factor. So, but the point here is that it depends that the amount will depend on the how much amount of the dust that you have used for the analysis. So, if you have used more dust, then this numbers can be higher or lower depending on the amount of the dust that you have used for the analysis. So, this enrichment factor, this formula does not hold good, and therefore, you have to normalize with any element which is actually very conservative, and as discussed, aluminum is very conservative elements, and this has been used to here actually. So, enrichment factor is generally calculated with respect to this one. So, now if you see here, if you talk about the ratios, like you have here zinc, copper, cadmium, manganese, lead, nickel and chromium. You see that natural ratios, if they have a natural origin, their ratios should be here somewhere around. Okay. But because their ratios are much higher, except manganese and little bit copper, also other elements like zinc, cadmium and lead, nickel and chromium, they are mostly derived from the anthropogenic activities. So, if you are finding a samples or who is this, you see such kind of enrichment, you can very clearly see that these aerosols are actually like derived from the I mean they have been influenced significantly from the anthropogenic emissions of the heavy metals. So, like industries and vehicular emissions. Okay. So, for example, one of the things is important here, that zinc and nickel, we usually use them as a vehicular emission source. So, this is also very important. So, except magnesium, almost all the elements shows the anthropogenic emissions, and then you see the lead also is there, and this lead actually initially was because we are using tetraethyl lead, that was used as actually anti-knocking, sorry, this is not anti-coding, anti-knocking. Okay. So, lead was used as anti-knocking agents in the diesel vehicles. So, that was giving a huge amount of lead, but the good news is because lead is very toxic, the government has recalled this, and they have based on the recommendations, the use of tetraethyl lead has been banned actually. So, we are not using now tetraethyl lead in the what you call in the diesels, because if you use the anti-knocking agents, it will increase the kind of octane value. So, it will enhance the what you call the combustion and other things. So, all these heavy metals are highly toxic to the human as well as the ecosystem. So, this is very important, and that is why urban road dust, if you see this one, even urban road dust, because they contain lots of heavy metals which are toxic compared to the natural dust, they can be more toxic to the human as well as ecosystem. So, compared to the natural dust, which has significant, although it has significant amount of other metals or major elements, which to have the impact, which to impact the human health, but when you increase the some of the toxic levels of heavy metals, the toxicity increases further. This was one of the things that we were trying to do. This was the example from the Patna. So we were trying to know that can riverbed be a major source of road dust in PM10 or dust aerosols in the PM10. So we collected the road dust samples from there and we segregated them in different fractions. So if you see here, less than 25 micron is actually 0.3% only. So this means this is not contributing much in the PM10, but at the same time, because we use the capital size, the higher size up to 75, so this means they could be an important source of road dust. So they can be transported and deposited back on the roads, and when the vehicles movement happens, these road dust can be broken into smaller pieces. Okay, so road dust emissions and resuspensions as well as construction demolition activities seems to be major contributing source of air pollution, especially PM10 and road dust in Patna. And then we estimated that top 3 contributors were road dust, which is contributing about 30%, construction and demolition activities constituting about 25%, and vehicular alone contributing about 23-25%. So you can see in the urban areas, the much of the source, even if you just see the dust aerosols, so 30 and 25, it becomes 55%. 55% is just contributed by the dust, and this dust is very important. And mind you that dust, these dust are, as we discussed in the previous slides, these dust, road dust, they contain kind of very heavy metals which can be very toxic. One of the things that I have not discussed in this one is actually like what you call, there are significant amount of polyaromatic hydrocarbons that are present in the road dust. So this is another very important and emerging area, and I think all the MSc, if you are doing dissertation or especially the PhD students, this must be tackled down. For the policymakers, road dust control is necessary actually, if you want to really control the urban air pollution in the city. So road dust emission needs to be controlled. So we also did some experiments in the Prayagraj, and there we wanted to see that how their composition of the road dust is there with the composition of PM 2.5, and you can see here, you see this blue fraction, I am sorry I can't read this one. So calcium is dominant in the road dust as well as in the aerosols. So this means they do have, both have very significant, they have significant source of geogenic sources, but we found that chloride, sulfate and nitrate are the elevated levels in the aerosols, but they were less in the road dust. So this means there is an increased contribution from the vehicular and coal combustion. This is further substantiated by the fact in the last slide that we discussed that zinc and nickel in the road dust and aerosols, which are actually derived from the vehicular emission. So again, this pointing out that road dust is actually a mixture of geogenic or natural aerosols as well as the contribution from the vehicular emission and coal combustion. These are some of the diagnostic ratios that are usually used, and then for example here in the I discussed that aluminum is used for the dust as a tracer. Usually here in the reference element we use sodium plus, okay, when we measure the ions, okay. So sodium is taken as a conservative elements here, and if you see the most of the ratios like sulfate to sodium, if the sulfate to sodium ratio is more than 1, this means actually kind of anthropogenic activities. Similarly, if the chloride to sodium, chloride is always, for example, sodium and chloride, they are always associated together. So the ratio should be, if you just see this one, the ratio should be somewhere around 1.6 molar ratios, but if you are getting less than if you are getting chloride less compared to the sodium, less than 10, they are again coming from the biomass and coal combustion. So potassium, for example, and calcium to sodium ratios here, magnesium to sodium ratio, these two are very important for the dust characterization. So if you found the ratios are higher than this. So, for example, calcium to sodium ratios were more than 1 during summer season, but the ratios become less, actually 0.3. So, summer season you can see very clearly the dominance of road dust aerosols, but in the winter season the dominance of dust aerosols is not there, the dust aerosols contribute less. Of course, there are other tracers, we will discuss these things. You can use nitrate to sulphate and ammonium to sulphate ratios to distinguish whether this is a mobile source or a stationary source. So, mobile source like vehicles, okay, and if the ratios are more than 1, then is a mobile source, less than 1 generally indicates a stationary source. So, a stationary source means the source is not moving. And then ammonium to sulphate ratios can be used for secondary inorganic aerosol formation. So, these are the some of the tracers where you can use diagnostic ratios to distinguish the source of aerosols, especially road dust. So far I talked about dust. When you say dust, dust is actually majorly sodium, you have magnesium, calcium, iron, okay, aluminum. These are the very basic things that are there, and these are called major elements, okay. Anyway, and then I talked about this elemental composition, how the elemental composition is different of elemental composition of dust, which is actually I said here natural versus anthropogenic dust, or you can say actually road dust. We generally most of the time you can call this as a road dust. So, we discussed about the composition, how the composition of these elements are different in this one. We discussed about the enrichment factor, that is very important, and we discussed about the how enrichment factor can be used to distinguish the sources of the aerosols, whether they are natural or they are anthropogenic. One of the things that I have not discussed this one, like you also look like physical, because this is topic of research. So, I am not discuss this one, but I am just giving some clues here. Scanning electron microscope, so if you do the same study, you can see the different particles that are embedded within this one. So, if you do the scanning electron microscope, you will be, because when the aerosols is emitted, this aerosols is actually like a single entity, but when this aerosols goes into the atmosphere, what will happen? Lots of things will be actually, we will be discussing about this, that is actually called mixing state. I do not know if we will have some time to discuss this one. So, this dust aerosols are aerosols that is suspended in the atmosphere. You have actually like gases like HNO3, you have H2SO4, you have secondary organic aerosols, you have water vapor, okay. So, these things can be actually condensed on these surfaces. Not only that, the smaller particles of aerosols, they can be attached to this one, and these smaller particles can coagulate. So, in principle what you will see different kind of aerosols that are embedded in between. So, actually you will not see the natural original signature of aerosols. So, this is the original signature. What you will find here, this dust aerosol is composed of so mixed aerosols. So, it is there are actually another terms here that we will be discussing about. It is internal or external mixing. We will discuss these things actually in this one, that whether the particles are just attached or they are actually mixed together. So, the composition of the elements that is there initially, it can be actually different, and they have a different role in the climate. And then for example, here this particle is there, what will happen? Suppose this is a dust particle, and then it contains lots of minerals here. So, some of the particles are deposited, they will try to leach out the dust from the surface, and once they are trying to leach out, many of the elements which are actually like nutrients, we will discuss in the, but just give you some idea. In the next lecture we will be discussing about the nutrient cycle. So, nutrients, some of the nutrients can be leached out from here. So, when these nutrients are leached out, what will happen? These nutrients will be leached out and they will become nutrients will be labile actually. So, they can leave these aerosols, and if you just collect these aerosols, you will have something more soluble, and then it will be aerosols will become more soluble, and this solubility will increase, that more of the you can have more of the nutrients like that, like the iron, and then especially the iron, nitrogen and phosphorus, they can be deposited together over the other regions. So, they can contribute significantly. The point that I am trying to say, that aerosols is a very complex system. They can, when they are originated, their characteristics and other things are very different. Similarly, dust aerosols, when they are emitted they are very different, and when you look them into the atmosphere, through the other chemical properties. So, aerosols from the origin to the finally when they are there in the atmosphere, they are very different, and this causes a very different kind of composition, solubility, and then atmospheric chemistry. So, they affect almost everything that is there in the atmosphere. So, I think I have covered about this road dust. The next lectures we will discuss about the nutrient cycle and what are the nutrients that are considered and how we can study them, and probably we will also study some of the things like mixing state, radiative, how it contributes to the radiative forcing by changing the optical properties of aerosols. I am not going to discuss much on the scanning electron microscope image because it becomes too complicated, but it is very important for all the research scholars and PhD students. So, if you are MSc or PhD students, you should be doing this. This is very important. This is a kind of first signature that you can do here. And then there is another topic that is there actually, EDXRF, energy diffraction X-ray fluorescence studies, which is used to measure the elemental composition of the elements. So, some of the techniques I will cover probably in instrumentation techniques, not instrumentation techniques. We are not going to cover much of the instrumentation techniques in the in this course. It will be mainly a brief overview of aerosols and how it is measured, and then their implications in the atmosphere. So, I hope you have enjoyed the lectures, you have understood things that are related to the road dust and urban dust, and our anthropogenic dust, our urban dust, our road dust versus the natural dust, and then their composition and other things. So, I stop here with this lecture. So, thank you very much again.